Welcome to 7.10 Discontinuity and Limits. Today we are going to practice discontinuity and limits while graphing rational function using Frady. So we are still following the steps of Frady. However, this is the last addition to the Frady problem. So first let's look at example 1. Our first step is always to factor. So I'm going to go ahead and factor x squared because x squared is multiplication. I'm going to factor it to be x times x over x. Now, something we haven't dealt with before is what happens when I have the same factor in the numerator and the denominator. Well, normally when I approach a problem like this, they cancel out. Same thing occurs. So I'm going to cancel out one of the x's in the numerator with the x in the denominator. And what that's going to do is create a hole at that value. So what you do is you take the factor, you set it equal to 0. Now this one's pretty easy because it's just 0. And one thing that we have to do is now that I've canceled it out, these two factors are gone. So our only problem that we would be doing Frady on is just this singular x. Now, this creates an interesting problem for us because now I'm considering f of x is equal to x. And when I do that, it becomes a linear function, which means I'm no longer doing Frady. I no longer have a rational function to graph. So what you can do for this problem, and this problem only, is cancel out the rest of Frady. All we are dealing with is f of x equals x. Now we do have the instance of this hole. So what we'll have to do is take this x equals 0, plug it into our new function, and that's going to give me y equals 0, which is going to create a hole at x is 0, y is 0. Now around that, I'm just going to graph f of x is equal to x, which is just a linear function with a slope of 1. Okay, let's go ahead and look at example 2. I'm going to start off by factoring. My numerator factors to be x plus 3, x minus 3. My denominator factors to be x plus 2, x minus 3. Now I notice that I have the same factor in the numerator and the denominator, so I'm going to cancel that factor out, and it's going to create a hole at x equals 3. Now I just set x minus 3 equal to 0. That's where I got x equals 3 from. So I'm left over with x plus 3 over x plus 2. So this is the problem I'm going to do Frady on. That is very, very important for you to remember. These two factors are gone. They no longer exist for this problem. So what I'm going to do before I move on to the rest of Frady is I'm going to figure out what the y value is when x equals 3. So I'm just going to plug in 3 everywhere I see x, and that's going to give me 3 plus 3 over 3 plus 2, which is 6 over 5. So I'm going to have a hole at 3, 1.2 approximately. So I have my hole drawn in on my graph. Now, if you're drawing this on your own paper, basically I just have an open circle in that position. So my roots come from my numerator. I'm going to set x plus 3 equal to 0. My first root is going to be at negative 3, 0. Asymptotes come from the denominator, so I'm going to have an asymptote, a vertical asymptote, at x equals negative 2. I don't have any twins. I only have two factors, so I have no tangency, no togetherness. End behavior, if I look at the highest exponent, I have an exponent of 1 and another exponent of 1. Since the exponents are the same, I divide my coefficients. My coefficient is 1 over 1, so my horizontal asymptote is at y equals 1. For my y-intercept, I'm going to go ahead and plug in 0 everywhere I see an x. So I get 3 over 2. My y-intercept is at 0, 1.5. Now again, the features are not the difficult part. You know how to do this very well. It comes down to where do the curves go. So again, remember every vertical section is going to have a curve. So I have one vertical section, two vertical sections. Remember, it's split by my vertical asymptote. So I know I need one curve here, one curve here. So you have to decide, am I going to put it in the top or am I going to put it in the bottom Remember that if you have intercepts, you have to pass through them. So since this section underneath the horizontal asymptote has an intercept, I know I need to place my curve here. So it generally comes along the horizontal, and it's going to go through my intercept down along my vertical asymptote. Now remember also, you cannot cross a axes without an intercept. So when I look at this bottom section over here, I don't have any x-intercepts and no y-intercepts, so there's no way I can place my curve here. Another giveaway is the fact that I do not have togetherness. So since this piece is starting at the bottom and there's no togetherness, I know my second piece needs to start at the top. It's going to come through my y-intercept. Now it's going to have a hole, so I'm going to skip over this open circle, continue on the other side. Make sure that your holes are very obvious and that you know a hole is there.
Moving on to example 3, I have graph f of x equals x cubed minus x over x squared plus x minus 2. So the first thing I'm going to do is take my numerator. I notice that I have a term in common, so I'm going to take out that GCF of x, leaving me with x squared minus 1. Now I'm going to factor. That's going to give me x plus 1, x minus 1, because that's a difference of squares, over x minus 1, x plus 2. So when I see these two factors that are the same, I know that they are going to cancel out, giving me a whole at x equals 1. Remember, take the factor, set it equal to 0, x is equal to 1. So the problem that I'm actually going to be doing Frady on is x times x plus 1 over x plus 2. Again, remember, we are working with the problem with the whole canceled out. So before I move on, I'm going to go ahead and figure out what the y value would be for this whole. So I'm going to plug in 1 everywhere I see an x. So my y value would be 2/3. So I went ahead and placed my whole on my graph. Now I'm going to focus on my problem, set my roots equal to 0. So I'm going to have a root at 0, 0, and a root at -1, 0. Asymptotes come from my denominator, so I have an asymptote at x equals -2. I don't have any twins, so I'm going to have no tangency and no togetherness. Now, one thing I'm noticing here is if I were to multiply this back out, I would get x squared plus x. That would be an exponent of 2 over an exponent of 1, which for us means we are going to have BOTSA, bigger on top, slant asymptote. Anytime we have a slant asymptote, we have to divide and ignore the remainder. So I went ahead and expanded this top numerator to be x squared plus x divided by x plus 2. I'm going to approach this problem as synthetic division. You could do long division. It would work out just as well. But because my divisor is of the form x plus k, I can do synthetic. So I'm going to first set my divisor equal to 0 to get my box number. So it's going to be a -2 in the box. And then I'm going to write out my coefficients. So I have a coefficient of 1, a coefficient of 1. And normally we would have a constant. So I'm going to put a 0 here just to fill in that missing gap. Now, when you do synthetic division, you are going to bring down the 1 and you multiply. So -2 times 1 is -2. You add these two together, so I'm going to get -1, and we repeat the process. -2 times -1 gives me +2. Add these two together, gives me 2. Now we are going to always ignore the remainder when it comes to slant asymptotes. So I get y is equal to x, because the coefficient is 1, minus 1. So I went ahead and remember the part here is your shift up or down. So we normally have our linear function starting at 0, 0. We've shifted down 1. I have a coefficient of 1, so my slope is 1. So up 1 over 1, up 1 over, up 1 over, and so on. last but not least, our y-intercept. I'm going to go ahead and take my function. I'm actually going to work with this one and plug in 0 everywhere I see an x. That gives me 0 over 2, so my y-intercept is at 0, 0, which we already have graphed because it is also our x-intercept. So let's go ahead and look at the curves. Now, I do have two vertical sections, one here, one here, so I should have two curves in my graph. Now, I notice up top, I don't have any intercepts, so I cannot place my graph here. So the only place it's going to fit is down here in this bottom section. Now, for this one, I have a lot going on up here. So I know pretty obviously that my curve is going to go up top. Also, again, we do not have togetherness, so it must start up here. So it's going to start up here, go down, pass through my x-intercept. Now, I don't have tangency, so yes, it's going to go through, but it's going to have to come back up and go through my other x-intercept, almost pass through my hole, but not go through it, and pick right up on the other side and follow along the slant asymptote. Okay, limits. So we are going to briefly introduce the concept of limits, but this is something you're going to explore further as you get into pre-cal and eventually calculus. So use the graph to determine the following values. Now, the hardest thing about limits is being able to interpret what they are asking you. So I went ahead and for these first couple of questions, I have put this statement into words. So first line is going to be read as x approaches 3. Now, this plus sign is indicating I'm approaching 3 from the right. Y, which is the same thing as f of x, is approaching. So I'm going to go ahead and look at my asymptote. X is equal to 3. Now I am focused on what are the y values doing as I approach from the right. So as I approach from the right side of the line, my y values appear to be continuing and increasing up. And they're going to keep increasing up until they get to positive infinity. Now, on the other side, as x approaches 3, I'm approaching from the left. Notice I have a minus now. What are my y values doing? Well, if I look on the left-hand side of x equals 3, it appears that they are going down. And they're going to keep decreasing and follow along this vertical asymptote until they get to negative infinity. Now, another question that gets asked as x approaches infinity. So as x is going out to infinity, so I am going to, let's highlight this in a different color. As x approaches infinity, so as I keep going out in this direction, out here, what are my y values doing? Well, if I follow along my line, my y values are getting closer and closer to y equals 0. So y is going to approach 0. Same thing on my last one, but in the opposite direction. As x approaches my negative infinity, so I'm going out in this direction now, going out to the left. As x approaches negative infinity, my y values seem to be increasing, but they're eventually flattening out to be the same y equals 0 value. So as x approaches negative infinity, y is going to approach 0. Now let's go ahead and look at another example. Use the graph to determine the following values. So I have a vertical asymptote at -3. So I'm going to go ahead and highlight it so I know what I'm focusing on for my first two pieces. So as x approaches -3 from the right, so I'm coming this direction in, I'm going to follow along my curve and I see that it's increasing. It's going to keep increasing all the way up to positive infinity. So positive infinity. Remember, we are interested in what are the y values doing. These y values will keep increasing and keep going up. Okay, as x approaches -3 from the left-hand side, my y values appear to be going down, and they will keep decreasing all the way to -infinity. As x, so let me go ahead and highlight my next asymptote. As x approaches 5, so here's my vertical asymptote of x is equal to 5. As we approach from the right, I'm going to find my curve, and I see that my curve is going down. So I'm going all the way down to -infinity. As we approach from the left, I see my curve going up. So it's going up to +infinity. Now, the last thing we're going to check is what's happening as x approaches infinity and -infinity. So instead of looking at a vertical asymptote this time, we're kind of really focusing on what's happening at this horizontal asymptote. So as x is going out, which x is going out to +infinity, my y values seem to be getting closer and closer to y equals -1 because my horizontal asymptote is at -1. And as x goes out to -infinity, my y values seem to be getting closer and closer to that same value. Y is equal to -1. So one thing that I do kind of give you a helpful reminder, if we have an asymptote that we're approaching, generally you're going to have positive or negative infinity. That's just how it's going to work. If you're approaching infinity or negative infinity, it's going to be a value. That kind of helps you differentiate between what is the question actually asking you to find.